Okay, let's get started with this deep dive. You sent over some really interesting stuff linking calculus with forest ecosystems.
Yeah, it's a great connection. We're looking at sources on, well, differentiation and integration from a math perspective, and then integration in forest resources technology.
Right, and what really jumped out was this specific application you highlighted, calculating the total seed dispersal over time.
Mm-hmm. It's pretty cool, isn't it? Seeing how something that can feel quite abstract, integration, actually helps us understand something so tangible, so ecological.
Absolutely. It takes it out of the textbook. We're not just talking areas under curves in the abstract. We're talking about like actual seeds in a real forest.
Exactly. And think about why that matters for, say, forest resources technology. You need to understand how a forest regenerates,
For sure.
how many seeds are actually getting dispersed. But, I mean, how do you measure that? We're talking potentially millions of seeds over a whole season across maybe huge areas. You can't just go out and count every single one.
No way. And it's not like trees just drop seeds at one steady rate, is it? Your sources mention things like wind speed, different times of the season.
Right. Animals moving them around too.
Yeah, maybe different species are active at different times, so the rate is constantly changing.
Precisely. And that changing rate is exactly where integration becomes, well, essential. If you can get a handle on the rate seeds are dispersing at any given moment, let's
Yeah.
call it, our RDE is time.
Okay, RDT for the rate.
Integration is basically the mathematical tool that lets you add up all those tiny instantaneous rates over a whole chunk of time, say from the beginning of spring to the end of fall.
Ah, okay. So you integrate that rate function, RDT, over your chosen time period.
You got it. And the result of that integral, that's your grand total, the total number of seeds dispersed during that specific window.
That makes sense. So like differentiation might tell you the fastest rate, the peak moment when the most seeds are falling per hour, maybe?
Exactly. The peak rate.
But integration takes all the rates, fast, slow, medium, all through the season, and sums them up. Kind of like using your car's speedometer reading every single second to figure out the total distance you drove.
That's a great analogy, yes. It accumulates the effect over time. And this total seed number, it's not just, an interesting fact.
Right, the sources stressed its
But,
importance.
it's critical data for foresters. They use it to predict how well an area might regenerate naturally, or maybe where they need to plan reforestation efforts. Understanding that total seed output is like foundational for managing the resource properly.
So let's just sort of recap that for you, the listener. This dive shows how integration, a concept from calculus, becomes a really practical tool in forest resources technology.
Yeah, it lets people take something dynamic, like seeds dispersing at ever-changing rates.
And quantify the total result over time, which gives them solid data for managing forest health and planning for the future.
It's a really neat example of abstract math solving concrete environmental problems. It connects those dots beautifully.
Definitely. Okay, so here's a final thought to leave you with, building on this connection we've discussed. Think about where else calculating a total accumulated quantity over time using integration might be useful.
Yeah, what other natural systems? Or even technical fields.
Could you use it to figure out the total volume of water that flowed past a point in a river over a year if you knew the flow rate changes?
Or maybe the total amount of carbon dioxide a growing forest pulls from the atmosphere over decades, knowing the rate varies.
Exactly. What other processes out there could be better understood, or maybe managed, using this powerful idea from calculus? Something to chew on.